here we go, solving three variable systems. Okay, so three variable system is basically what you see. It is three variables, and usually with three variables results in three separate equations. So here's our three variable system. And I numbered the equations just so it's easy to refer back to them. Okay, now in order to solve a three variable system, we need to actually break it down into what we know, which is a two variable system. So we're going to look at these three separate equations, and we are going to pair two different sets of them together. So for instance here, I paired 1 and 3 and 2 and 3. I did that because I looked at every term in each equation and I said, all right, I need to eliminate one of these variables. So which variable would be easiest to eliminate? And I happened to look here at the y's, and I saw that every single one of them were 5s. We had 2 negative 5s and 1 positive 5. So if I paired the number 1 and 3, the negative 5 and the positive 5 would eliminate. And if I paired 2 and 3, the negative 5 and positive 5 would eliminate. So I was like, all right, I can pair these together. I don't have any manipulation of the equations, and they'll be able to eliminate right off the bat. So that's what I did. So as you can see, our pairs here. Sorry, I'm just trying to move this out of the way. Let's use our elimination method and now add. So since one of our variables eliminates, we can add. So negative x plus 2x is x. The y's cancel, and then 1z plus negative 3z is negative 2z, and 17 plus negative 10 is 7. I'm going to do the same with group 2 and 3. Add. Negative 5x plus 2x is negative 3x. The y's cancel. 5z plus negative 3z is 2z. 5 plus negative 10 is negative 5. So now I created, look at it, what does it look like? It is a system of equations with two variables. Basically what we just reviewed, a two variable system of equations. I numbered them 4 and 5. So now we have equation 4 and 5, which I bring down here. I'm going to set them up, and I'm going to say, hey, look. The 2z and negative 2z are already ready to eliminate, so I don't really have to do anything except pair them and then add. So 1x plus negative 3x is negative 2x. Negative 2z plus positive 2z cancels. And then 7 plus negative 5 is 2. So I get negative 2x equals 2. So we solve it and get x equals negative 1. Now again, just like with the last lesson, in order to solve the system, I need to know both the variables x and y. Or in this case, to solve this system, I need to know all three variables, x, y, and z. So once we get x, we have to plug it back in then for either equation 4 or 5. It does not matter. It just has to be one of the two variable equations. So since x is negative 1, I'll plug it in. I think I plugged it in for 4 here. Yep, and I got negative 1 minus 2z equals 7. So I solved for z, added 1 to both sides, got negative 2z equals 8, divided by negative 2, and we get z equals negative 4. So now we have x equals negative 1 and z equals negative 4. So at this point, we have to take our equation, or take our variables and plug it back into one of the original three equations. So equation 1, 2, or 3. I believe I chose equation 1, negative x minus 5y plus z equals 17. So I have negative 1 minus 5y plus z, which is negative 4, equals 17. Sorry if I just made you sick by bouncing around like that. And then I solve for y. Negative 1 is positive 1, so I have 1 minus 5y minus 4 equals 17. 1 and negative 4 combined is negative 3, so negative 3 minus 5y equals 17. Add the 5y, add the 3, negative 5y equals 20. Divide then by negative 5, and we get y equals negative 4. And just like with last lesson, we write the system as an ordered pair. And again, it's alphabetical order, so x, y, z. Negative 1, negative 4, negative 4. All right, here. New system. So for this, I'm going to do the same thing I did before. I'm going to look at 1, 2, and 3, and I'm going to say, all right, looking at these, what's the easiest variable to eliminate, because I have to eliminate them? Is it my x's, my y's, or my z's? Looking at my z's, I might say, it might be z's. But then, because I compare those two together, but then I'm going to have to multiply both equations by something in order to eliminate z's in the other two equations. So then it might be y's, right? Well, the only thing with that is basically every time I have to multiply an equation by something, which again, not a big deal. Or it could be x's. It really doesn't matter which one you choose here. It's going to be about the same amount of work anyway, no matter which one. I chose x's. I wanted to eliminate x's. So in order to eliminate x's, I paired 1 and 2 over here on the left-hand side, and then 2 and 3. Now with 1 and 2, I wanted to eliminate the x's, so I multiplied the second equation by -1. So that's where my negative x minus y plus 4z equals -12 came from. And then I multiplied the second equation by -2 to eliminate our x's there. So I got -2x minus 2y plus 8z equals -24. And then same thing, we solve, we add to eliminate the x's. So I added both equations. So here, -6y plus -y is -7y. 4z plus 4z is 8z. -12 plus -12 is -24. Add the same thing here. -2x plus 2x cancels. -2y plus 2y cancels. 8z plus 5z is 13z, and -24 plus -15 is -39. I was, uh-oh, now what? We have both the x's and the y's canceled here. Actually, it's kind of awesome when that happens, because if you notice, I have a linear equation here. I have one variable. So all we got to do is divide by 13, and we get z equals -3. And then now I have one of my variables. So I can just take this z equals -3, plug it into this two variable system over here. And we will get -7y plus 8 times -3 equals -24, which results in -7y minus 24 equals -24. Add the 24, so we get -7y equals 0. Divide by the -7, and we get y equals 0. So we have z equals -3, y equals 0, and now we need to solve for x. So I plugged it in to the, which equation? The second equation. So I have x, which I don't know, plus y, which is 0. So x plus 0 minus 4 times -3 equals 12. Well, -4 times -3 is positive 12. So x plus 12 equals 12. Subtract the 12, we get 0. So we have x is 0, y is 0, and z is -3. So we write that as an ordered pair. So it's going to be 0, 0, -3. Here is this. Why don't you actually go ahead, pause the video, and try it right now. And then I will have, I will go through step by step the answer with you. Actually, first, why don't I give you the answer? So if you haven't paused the video yet, pause it now and do it. Here's the answer. If you missed it, make sure you pay attention and watch what I did. If you get it right, then you don't need to worry about watching the rest of this video. All right, well, the answer is, let me find it. There, -2, 4, -3. So if you got that right, skip on. If not, pay attention. All right, so to get that, there's our three variable system. We try to find the best variable to eliminate. Here, I guess I chose y just because we had a coefficient of 1 here. You could have done the same with z. I don't know why I chose y. I just thought it would be a good one. So I paired what looks like 1 and 2 together to eliminate the y's. For these two, I had to multiply the second equation by a -3. So that's where the 9x minus 3y minus 15z equals positive 15 came from. I added those together. 4x, the y's canceled. -9z equals 19. And then here, I paired 2 and 3 together. Again, I multiplied the second, or in this case, the first equation, but equation 2, I multiplied it by -2 in order to get the y's to cancel. So I got 6x minus 2y minus 10z equals positive 10. And then I can combine like terms. Then I add. 6x plus -4x is 2x. -2y plus positive 2y cancel. -10z plus 1z is -9z. 10 plus 13 is 23. So there is now equation 4 and equation 5. Unfortunately, nothing, two variables did not cancel out for me. So I create a two variable system with equation 4 and equation 5. The only thing I did with equation 5 is I multiplied everything by a negative in order to get my z's to cancel. So negative 2x plus 9z equals negative 23, and then I add to eliminate there, and I get positive 2x equals negative 4. Divide by 2 and get x equals negative 2. And once I got x equals negative 2, I plugged it in to equation 4 for the x variable there. So I got 4 times negative 2 is negative 8. So negative 8 minus 9z is 19. Add 8. Negative 9z equals 27. Divided by negative 9, I get z equals negative 3. So I have x is negative 2, z is negative 3. So I took that and I plugged it into that equation, negative 4x plus 2y plus z, which I believe was equation 3. So I plugged it in the third equation there and simplified it down, solved the equation, and got y equals 4. And so there's our solution, or that's how I wound up with a solution of negative 2, 4, and negative 3. Thank you, and if you have any questions, make sure you write it down, and don't forget to ask it tomorrow, or now, because you're actually taking this in class.